This is our subject, data engineering. And if you look at the textbooks, this is the standard textbook, Fundamentals of Data Engineering, Plan and Build Robust Data System by Joe Rees and Matt Housley, first edition. And this is that book. Okay. So here it started with defining what exactly is data engineering, because we know that data analytics, data science, data engineering, predictive analytics, descriptive analytics, visualization, dashboards, uh, they blur the definitions, overlapping concerns are also there. So here the author first tried to decipher the definition of data engineering and what exactly is a data engineer. So first what he did is he just extracted few definitions by different authors. One of the definition is given by Alex Soft. What he says, data engineering is a set of operations at creating interfaces, mechanisms for the flow and access of information. It takes dedicated specialists, that is data engineers, to maintain data so that it remains available and usable by others. In short, data engineers set up and operate the organization's data infrastructure, preparing it for further analysis by data analysts and scientists. According to Jesse Anderson, the first type of data engineering is SQL focused. The work and the primary storage is in relational databases. All the processing is done with SQL or SQL based languages. Sometimes ETL tools are used. ETL stands for extract, transform, load. The second type of data engineering is big data focus. So the work and storage is in big data technologies like Hadoop, Cassandra, HBase. Processing is done in MapReduce, Spark, Flink. The primary processing is done in languages like Java, Scala, Python. Maxim's definition, what it says is, it's a superset of business intelligence and data warehousing, and also addition of some elements of software engineering. Integrate specializations around operations of so-called big data distributed system, along with the concepts of Hadoop, stream processing, and in computation at scale. According to Lewis Gavin, data engineering is all about the movement, manipulation, and management of data. These are the different authors and their interpretation of definition of data engineering. So now the refined definition given by the author of the book. What is the name of the book? The name of the book is Fundamentals of Data Engineering by Joe and Matt. What it says, data engineering is the development, implementation, and maintenance of systems and processes that take in raw data, produce high quality, consistent information that supports downstream use cases such as analysis and machine learning. Data engineering is the intersection of security, data management, data operations, data architecture, data orchestration, software engineering. A data engineer manages the data engineering life cycle, beginning with getting data from the source system and ending with serving data for use cases such as analysis of machine learning. If you look at the data engineering life cycle, it starts with data generation. You can see 1, 2, 3, 4, 5 stages are there. Data generation, data storage, data ingestion, data transformation, data serving for analytics, machine learning, reverse ETL. And you have undercurrents or intersections in the form of security, data management, data ops, data architecture, orchestration, software engineering. Always there is a confusion, right? That data engineering is a sub-discipline of data science or analytics. But the claim is data engineering is separate. It is sitting upstream from data science. Means data engineers will be providing the inputs used by data scientists. Yeah. So let us try to differentiate between data science, data engineering, and data analytics. Let us say with few applications. If I look at data science, prediction is one of the application. Okay, NLP or image is one of the application. If you look at data engineering, building data lakes, data streaming, pipelines, infrastructure building, this can be data engineering. If it is data analytics, then sales trends, behavior tracking, performance reporting, as far as applications are concerned. If you look at the tools and technologies, data scientists will be using Python or libraries such as Scikit, PyTorch, TensorFlow, Pandas, NumPy, Databricks, Matplotlib. While data engineers will be using SQL, Python, Java, Scala, ETL tools like Apache Airflow, Talent, Informatica, big data tools like Hadoop, Spark, Kafka, databases like PostgreSQL, MySQL, MongoDB, Redshift, Snowflake. While data analytics people may be using Power BI, they may be using Tableau, ClickView, spreadsheets, Google Sheets, R, and so on. So, what are the outputs or deliverables of a data science model is predictive models, classification, regression, recommendation systems. While for data engineering, it is data pipelines and storages. While for data analytics, it is dashboards, KPIs, so on and so forth. This is an introductory session, so we'll stop here.